Hi, I'm Charles, and today I'm going to be discussing Newton's universal law of gravitation. Here we have our main equation. The force of gravity is equal to big G times big M times little m over r squared. Now, big G is our gravitational constant, and that is 6.67 e to the negative 11 Newton meters squared per kilogram squared. Now, as you can see in the diagram, we have two masses attracted to each other, m1 and m2. Now, distance d, or r, is measured from the center of mass 1 to the center of mass 2. And now, if mass 1 is larger than mass 2, in orbit, mass 2 will be revolving around mass 1. Now I'm going to discuss some common misconceptions when it comes to using Newton's universal law of gravitation. First, big G, or the gravitational constant, is different from little g, or acceleration due to gravity. Be wary of this. Second, r should be measured from the center of each mass, not their surface. Now I'm going to talk about when we use this concept when solving physics problems. First, we are going to solve for the gravitational force between two objects, and then we're going to solve problems involving planetary orbits, like solving for the velocity of a planet's orbit. First, we are going to determine the gravitational force between the Earth and the Moon. I've already found our constants and the things we need to Google, like the mass of the Earth, the mass of the Moon, the distance between the Earth and the Moon at their centers, and of course our gravitational constant, big G. Now we use our equation. The force of gravity is equal to big G times big M times small m over r squared. Now we plug in our values, which we all had given, and we come up with our final answer, 1.985 e to the 20th newtons. Next, we are going to find the speed of the moon's orbit around the Earth using our previous answer from number 1. Now, the net force is 0, and the net force is Fg minus Fc, so the gravitational force is equal to the centripetal force. Now, centripetal force is the mass of the object moving times velocity squared over r. And our object moving is the moon. So we set Fg equal to centripetal force. Now we plug in our values using our Fg from the previous answer, and we come up with our velocity of the moon, which is 1018.49 meters per second. Okay, now all the work we've done previously in this video has led up to this final problem. How long does it take the moon to complete one rotation around the Earth? We already have our radius and the velocity, which we found in the last part. Now we use circumference to find the distance. Circumference is 2 pi r. So we plug in our values, and for circumference we get 2.4127 e to the 9th meters. Now this is the distance that the moon is going to cover in one rotation. Now we use our equation v equals d over t. V is our speed in this case, which we know, and d is equal to circumference. So t is equal to c over v. Now we plug in the values for circumference and for velocity, and we get that t is equal to 2.369 e to the 6 seconds. And this is approximately 27.3 days. Thank you for watching, and good luck on the AP.